All right, guys, so what we're looking at today is absolute value problems, but these will have absolute values on both sides for some, and some of these we're going to have to check to make sure the answers do work, because there's some that we might have that won't. Now, to solve an absolute value where we have absolute value bars on both sides, we're going to pick one side or the other to make it positive and negative. So when we look at this here, the absolute value of 3x minus 4 is equal to the absolute value of x. We have absolute value bars on both sides. So what we're going to do is we're going to pick the right or left side, so it doesn't matter which. We'll say the right side, this one here. When we drop the absolute values, we have a case where it's positive and a case where it is negative. We're going to do one in both. And we only have to do it to one side. We don't have to do it to both. But otherwise, this is going to be the exact same as what we did yesterday. So if 3x minus 4 is equal to x, and 3x minus 4 is equal to negative x. Now, what we need to do is we need to get the values of the x on the same side. So we can move the 3x to the other side, or we can move the x. What do we want to do? Do we want to move the 3x, or do we want to move the x? So we can by subtracting x from both sides. Because when we subtract x from both sides, x minus x will cancel, leaving us with 0, yes? 3x minus x is 2x minus 4. So we have all the x's together, yes? Now we need to get them by themselves. So the negative 4, the minus 4, we need to move it over. And the main way we can move negative 4 over is by adding what? Positive 4, or adding 4 to both sides, because negative 4 plus 4 will cancel, leaving us with 2x is equal to 4. And what do we need to do next? We need to divide both sides by 2, which tells us x is equal to 2. Any questions on this here? We good with this here so far? Yes? So we'll have to do the same thing on the other side. Now this time I'm going to subtract 3x first instead of subtracting x. So we'll do it the other way. We'll move the 3x over. Well, 3x minus 3x is 0. And what that leaves us with is negative 4 is equal to, well, negative x minus 3x is negative 4x. So do we have x by itself? We have all the x's on one side, don't we? But they're not quite by themselves. We have what with it? We have negative 4, yes? So to get the negative 4 away, we have to divide both sides by negative 4. And if we divide both sides by negative 4, well, negative 4 divided by negative 4 is 1, or we just have our x, because everything else simplifies out, yes? Well, here we have negative 4 divided by negative 4, which should give us 1. So we found the values of x to be 1 and 2. I'm just going to write it over here for reference. So any questions on anything we've done so far with these here? We good with these two problems? Yes? And that's it. Now we can check it if we wanted to. So I could plug it back in 3 times 1 minus 4 is equal to the absolute value of 1. So it'd be 3 minus 4, which the absolute value of 1 is 1. It works. And we could do the same thing with 2. 3 times 2 minus 4 is equal to the absolute value of 2. 3 times 4 is 6. It works out both of these work. If we plug them back in, they will both give us a true statement. Questions on this here? Not too bad? All right, so again, we have two absolute value bars, one on each side. Now, we're not going to worry too much about the 2. It's not going to really come into effect. But we'll set up our two equations. 4x minus 10 is equal to 2 times 3x plus 1. And then we'll have 4x minus 10 is equal to what? Negative 2 times 3x plus 1. Because we're going to have one side positive, one side negative. So we have a case where one side is negative, and we have a case where it's positive. Which one do we want to solve first? The one on the right or the one on the left? Doesn't matter which. We can do the one on the left. So what do we need to do first in solving this here? Yeah. We need to distribute the 2. We need to multiply through by 2. The 4x minus 10 isn't going to change. But here, 2 times 3x would be 2 times 1 is going to be plus 2. Because we multiply through by the 2. 2 times 3 is going to give us 6. 2 times 1 is going to give us 2. Any questions on this here? Now we need to get x's on the same side. So to do that, we're going to add or subtract something from both sides. Well, for this here, I'm going to move the 4x to the other side. So to do that, I'm going to subtract 4x from both sides, because when I subtract 4x from both sides, it's going to move it from one side to the other. So this 4x and this 4x will cancel. And all I have left on this side is negative 10 is equal to, well, 6x minus 4x will give us 2x, and then we have plus 2. Any questions on how we got to this point here? We good? Well, at this point here, we're going to do what? We still need to get x by itself, so we're going to subtract 2 from both sides. And when we subtract 2 from both sides, well, 2 minus 2 is going to cancel. So we just have 2x left on the right side. And over here, we have 10 minus 2, or negative 10 minus 2. And negative 10 minus 2 is negative 12. Which brings us to our last step, where we're going to divide both sides by 2. And when I divide both sides by 2, I get x is equal to negative 6. And that's it. Questions on any of this here? Questions on anything we've done so far? We good with these here? Yes? All right, well, we have to do the other side. So this time we're not going to distribute 2, we're going to multiply through by negative 2. Because negative 2 times 3x is going to be negative 6x. Negative 2 times 1 is going to be negative 2. But this time we're multiplying through by negative 2, not positive 2. So it's going to make the values change just a little bit. So to keep it kind of the same as we did previously, we can go on and subtract 4x from both sides. Because 4x minus 4x will cancel like it did before. So what that'll leave us with is negative 10 is equal to negative 6x minus 4x will give us negative 10x minus 2. Now we can keep with a similar step and we can add 2 this time because originally on the first time we did it, it was positive 2, so we would subtract 2 from both sides. This time we're going to add 2 to both sides. So negative 10 plus 2 is negative 8 is equal to negative 10x. And then last but not least, we're going to divide both sides by negative 10. And when we divide both sides by negative 10, we get x by itself. Negative and negative will give us a positive. And we have 8 over 10. Questions on any of this here? Now we could rewrite this because this will simplify to 4/5. So we can say 8/10 or 4/5. Either one will be the correct answer. Any questions on any of this here? Are we good with all this here? Yes? I want y'all to give this one a try. Work this one out on your own on your sheet of paper. Because I think most of y'all got the first one, because we can subtract x from both sides. But you end up getting 7 equals x. You might have done it a different way because there's different ways to go about doing it depending on what we do first. Okay? Now, so one thing we have to be careful with is when we do the negative case, we apply the negative to everything on this side we want to make negative. So you can do it with parentheses, or really what we have is x plus 8 equals negative 2x minus 1. So we have to change all the signs, because if we don't, it'll get you tripped up. Okay? Now we want to get all the x's on the same side. I normally try to keep x positive if I can. So what I would do is I would add 2x to both sides. Because x plus 2x is 3x plus 8 equals negative 1. From here, we can subtract 8 from both sides, which gives us 3x is equal to negative 9. And when we divide by 3, do you agree? Yes. There you go. Huh?
I got it right here.
Okay.
And then I was lost.
Okay, so when we have this here, we need to apply the negative 3 first. So negative 2x minus 1. So that subtract 8 is yes, that is right. This is good. Yes. Okay, we're getting it, we're understanding. Yes, I'm not just doing it. Is it okay? Okay. Do we need to see another example one of these? Yes? Okay. So when we look at this here, we're going to have 2 cases. This one here is going to be 3 times x minus 4. Here, we're just going to have 2x plus 5. Now, we're also going to have the negative case, yes? So here, this is 3 times x minus 4. Now, what we can do is we can just change the sign on everything of the side we're going to make negative. So we can do the minus and then put parentheses around it, or we can just flip all the signs. So if it's positive for this one, it's now negative. And if it was negative, it's now positive. We just flip the signs on one side, okay? So I could have rewritten this out as this here, but everything is going to switch to this here, to the negative 2x minus 5. Any questions on this here? So it might be easier to just go on and switch everything over negative 2x minus 5. That way we're not having to worry about it. Now the first thing we're going to have to do is we're going to have to multiply through by 3. We have to distribute the 3. So 3 times x is 3x. 3 times negative 4 is negative 12. So now we need to get x's on the same side, and then we're going to get the numbers on the other. So what do we want to do? What can we do next? What do you want to do next, Angel? Those two? So we want to move it to the other side? So how would I move it to the other side? I would subtract, yes. Because these here would 3x minus 2x, or 3 minus 2 is? So I have x minus 12 equals, so what's left with x? Negative 12, so what would we do? We would $12. Is negative 12 plus 12? That's it. Get a little more comfortable with this? Yes? Okay, so we're going to have to do the same thing over here. We'll distribute the 3. So 3 times x is 3x. 3 times 4 is negative 12. Minus 5. Now we can almost do the exact same steps as we did over on the other side the first time, but I can't subtract 2x this time. What do I have to do? We have to add 2x, because this time the 2x is negative. These will cancel because negative 2x plus 2x is 0. 3x plus 2x is now 5x. Now this time we can add 12. We can still have that same step. So here we have 5x still. Negative 12 plus 12 will cancel out. Equals. If we added 5? So let's see that. If instead of this, we could add 5 here. And we'd have 5x minus 7 equals 0, yes? Is the variable by itself? No, we got to get, now we have to move the 7, yes? So now we would add 7 to both sides. It would give us 5x, because 5x would now be by itself is equal to 7, yes? So it works. That's perfectly fine. The only downside to it is that we added an extra step, didn't we? Yeah, and that's fine. That's fine. That's perfectly fine. If you want to do it that way, go for it. Go for it. Because then our last step would be to divide both sides by 5. That's it. The reason I would add 12 instead of adding the 5 is because if I add the 5, I've got to move it back to the other side, yes? So when we add 12, we move it that way because it gets it away from x. Because our real steps for this here, our main steps, the way that I think about it is, step number 1 is to simplify parentheses, if there are any parentheses in the equation. Our second step is to combine like terms, if there are any. Get variables on one side and everything else on the other. And then get the variable by itself. So if we have to multiply or divide, we do that last. So does that kind of make sense? So we try to simplify, so parentheses, group-like terms, variables on one side, everything else on the other, get x by itself, or variable by itself. How many of y'all have heard of an extraneous solution? An extraneous solution is a solution that does set it like we get from doing the steps and doing the work, but it doesn't work in the actual problem. It doesn't work in the actual problem. So we have to check. So this one here is the first one where we're going to have to check a solution to see if it works. Our main steps are not going to change because we'll still have 2x plus 12 equals 4x. Because we've had the positive case and we also have the negative case, yes? So 2x plus 12 equals negative 4x. So let's use our steps that I kind of set up there, because I think most of y'all are pretty good with this here, yes? So some of these steps help us so that we don't have additional steps. There's nothing wrong. Because at this first part, we could subtract 12 for the one on the left from both sides. We could subtract 2x from both sides, or we could subtract 4x. None of those are wrong, because we can do any one of those. So what am I going to do first? Well, I think it'd be easiest, or the least amount of steps would be to subtract 2x from both sides. Because I already have 4x on one side, and I have 2x on the other, yes? So I can subtract 4x from both sides, or I can subtract 2x from both sides. It really doesn't matter. But then I notice what? This 12 is here, yes? Are there any numbers over here? No, so if I move the 2x over to the 4x, I have all the variables on one side, I have everything else on the other, yes? So subtracting 2x will get these to cancel. 12 on one side. 4x minus 2x is? So I have all the variables on one side and everything else on the other. So that's what I would subtract 2x. It's not wrong to subtract 4x from both sides, but then we'd have to subtract 12 from both sides. We'd have to move the 12 over. Okay? If you want to do it that way, that's fine. I'm not going to count it wrong. And then what do we have to do lastly? We have to divide both sides by 2. So 6 is equal to x. And we got our answer, yes? Okay, let's do the negative case. So again, I'm going to divide both sides, or subtract 2x from both sides. Because 2x minus 2x will equal 0. So 12 is equal to negative 4x minus 2x is negative 6x. And just like before, we're going to divide both sides by, well, this time it'll be negative 6. But I have negative 2 is equal to x, yes? So we did the steps and we got 2 answers, yes? But we need to check them. You need to check them. So we can plug it back in. 2 times 6 plus 12 is equal to 4 times 6. Well, 2 times 6 is plus 12. 4 times 6 is 24, yes? 12 plus 12 is? Absolute value 24 is 24. That worked, no big problem, yes? So let's do negative 2. So 2 times negative 2 plus 12. I'm going to only worry about the one side. 2 times negative 2 is negative 4. Negative 4 plus 12 is 8, yes? Absolute value of 8 is 8. Well, it said this is equal to 4 times x, so 4 times negative 2. Well, 4 times negative 2 is negative 8, isn't it? Is 8 equal to negative 8? No, right? So what we would say is that x equals negative 2 is an extraneous solution. An extraneous solution. It is a solution, but it doesn't work in the original problem. Does that make sense? So even though our method defining our values of x gave us that value, it just doesn't work in the original problem. Questions on this here? And coming up with solutions like this here aren't always uncommon. They come out. It happens. And we see these pop up a lot of times in real world application problems. Because y is the amount you make, and if you make $16 an hour, yes? So anything along this line would be the amount you make, yes? So 1, isn't technically negative 1, negative 16 on that line? Yeah, it's part of that equation, isn't it? Would that be actual realistic for this problem, or we're talking about hours of work and your pay? Can you work negative hours? But the equation does show up for negative hours, doesn't it? So there's some things that the equations in math that we do will give us values or have stuff for it, but it doesn't work back in the original equation or the problem type we talk about, okay? And that's kind of what the extraneous solutions are. Now,